Hello guys, welcome to the lecture series on Sage Math. Today's topic is we are going to explore one variable calculus with Sage Math. So let us see, explore the function f of x is equal to x sine 2x plus x square e power minus x plus x square minus x plus 3. So now I'm going to define this function as like this. Now if I want to show this function, you can just press F, or suppose if I want to visualize this function in equation way, let us see. I am going to write it as F and shift enter. So you can display like this. Suppose if I want to write it in equation format, write it as show of F. So function of x is nothing but x square e power minus x plus x square sine 2x plus x square minus x plus 3. So now I am going to plot this. So the plot of this will be like this. Now I am going to find the limit as a tends to x, a is equal to minus infinity, and I'm going to find the left side limit of this. So just run this, you'll get infinity for left infinity. I'm going to take it as plus infinity. Still its limit is infinity only. Suppose if I want to find it in numerical manner, I'm going to find the limit value at x is equal to 1. So we'll get limit value of that function at x is equal to 1 is this one. Now if I want to differentiate this, so this is the command for differentiation. df is equal to f dot diff, diff. So if you want to differentiate how many times, that you can mention in this bracket. So suppose if I want to differentiate for one time, you can mention it. So just I'm going to write it as show of diff. So you'll get a differentiation of that given function is this much. Now I'm going to differentiate this for one more time. So second derivative of f of x we got like this. In instant way we can get the second derivative. Or this is one more way of giving derivative, f dot derivative. So this is one more method of mentioning derivative of a function. So while you are mentioning like this, it will give in a text manner. Suppose if I want to integrate the given function, you can integrate this in this manner. Suppose if I want to visualize this, I can enter the command as show of f dot integral. So if you integrate the function f of x, it will give an instant result in the equation form like this. If I want to get equation form, so you have to compulsory use show command. If you want to get in a text form, directly you can write f dot integral of x with respect to x. Now this is also one more way of integrating this. Now I want to write it as a definite integral. So f dot integral from 0 to 1 in numerical manner. So let us see the definite integral of the function. So directly it will give the solution as 3 point something. If I want to find the Taylor series of this, so you can get the Taylor series of f of x also in this manner. So I want to get it in a equation form. I am going to press it as show of this one. So this is the Taylor series of the given function f of x. Now let us explore about the limits. Okay, now I'm going to take it as example as limit x tends to 0 cos x minus 1 divided by x square. So let us evaluate this limit using Sage Math. So I am going to define this as cos x minus 1 divided by x square, f dot plot of minus 2 to 2. So I am going to plot this function between -2 to 2. Let us see the function. It will be look like this. Now I am going to evaluate the right limit. So this is the command for right limit. dir is equal to plus. Now I am going to find the left limit. Now I am going to find the limit of that function f of x. So if the limit will exist only if it exists right hand side and left hand side, and you should get the same value. So it is going to satisfy that. Now I am going to explore the limit of this function. Limit x tends to 0, x square cos 2 pi x. Let us see. Just I am going to define this. If I want to press this as show, so just show of f. So it will give the function as x square cos 20 pi x. Now I want to draw the plot between -1 to 1, and figure size I have mentioned it as 4. Now I am going to plot in I am going to draw a set of plots. In plot 1 I am going to mention from -1 to 1. In plot 1 I am going to take it as x square, and in plot 2 I am going to take it as minus x square from -1 to 1. Now I am going to club all these graphs. Let us see. So this is a multi-step function I have mentioned, where f of x is equal to -1, and f2 of x is x square, and f3 of x is minus x square. So combined plot I have drawn like this. Now limit of that function f of x is 0. So directly you can mention the limit as limit of f of x where x tends to 0. Now exploring the limits of the function of the limits, that means f of x. This is one more example, that is f of x is equal to x by 2 power x plus x plus cos theta. So just I have mentioned that, have run this. Now I'm going to plot this again. So I'll get the plot like this. Now finding the limit as x tends to infinity, what happens? If you run it, you'll get the result limit value as 1 you'll get. Next just to define f, again I'm going to rerun it. This is minus infinity and this is plus infinity I have found. Now I am going to plot this function for 0 to 100. Y max is 2 and y minimum is -3. So x value I am taking from 0 to 100, and y value I am taking from 2 to -3 in figure size as this much. So you'll get the plot like this. Next I am going to plot in a different mode. That is when plot of function f of x and x taking from -1.2 to -0.8, and y max have taken from 100 and y minimum I have taken it as -100. So it will show the in detail. If you want to zoom any graph, you can zoom it in this manner. So now I am going to find the function at as x tends to -1. So directly you can get the answer like this. And function value at -1, will give this one. Next, again I'm going to take one more example. F of x is equal to this one. This we have solved in the notebooks in your classes. Let us see. The function I am going to define as like this: 1 minus x square. It has taken highest degree first, and now I'm going to plot the graph for this between 0 to 5, and color I am taking as red. So we'll get the plot as like this. Now I am going to find the left and right limits for this. 1 and 1 will get, and if you find the limit for this, since left hand side and right hand side limits is at 0 it is 1, and if you take a limit at x tends to 1, you'll get limit as e. So if I take the limit value at x is equal to 1 is e. So in this way you can find the limit of any function. So I have taken total 5 examples. That's it. With this I am going to end the session. Thank you for watching.